In this video, we will look at some basic probability vocabulary as well as some examples from the Unit 2 homework. We're going to be talking a lot about an event. Typically, we'll be looking at a successful event, and that's what we're interested in. An example, if you roll a die, that's a different probabilistic situation, but getting a 5 specifically is an event. The sample space is all of the possible outcomes, and the sample space is what makes up our denominator when we look at our probability. Our probability is the chance or likelihood that something will occur. It can be written as a ratio or a fraction, a decimal or a percent. And then all probabilities are between 0 and 100%. And then we'll be calculating probability either based on data, so we would have an experimental probability, which is the number of successful outcomes in the experiment divided by the total number of outcomes. Or if it's something that would be rolling a die or something where there's an equally likely chance of occurring, we could calculate the theoretical probability. These would be your dice problems, your card problems, or anything where you're given information about what it looks like. Okay, so let's use this information and look at some examples from this unit. Okay, I think this one we've already seen in the homework. If we take a look, it says the following shapes are in a jar. Evan reaches in and pulls one out. What is the probability that he pulls out a quadrilateral with parallel sides? So that is the favorable event. I know there are 6 shapes total, so my denominator is going to be 6. So then I'm going to go through and count my quadrilaterals with parallel sides. It looks like this is one here. This is a quadrilateral with 4 sides, 2 of them parallel. And then this one here, because of the right angles, I know that's a rectangle, and that's also parallel. So it looks like 3 of the 6 are quadrilaterals with parallel sides, and I could leave it as 3/6, or I could turn it to 1/2. The 3/6 is kind of nice because it tells me that it was 3 out of the 6 shapes. The second piece here asks me about a shape with rotational symmetry. So I'm going to go through here. Again, my denominator would be 6, and I'm going to look for all the shapes that have rotational symmetry. This square has rotational symmetry. I could turn it 90 degrees. And this parallelogram has 180-degree rotational symmetry. So it looks like 2 out of the 6, or 1/3, would have rotation symmetry. All right, next up we have an example with Mrs. Shreve and students in her class and students that are wearing glasses. This is similar to a homework problem, but I wanted to give you a little bit different numbers so you could try these problems separately. Okay, so if she has 24 students in her class, how many wear glasses? Well, I know that 1/4 of the students wear glasses, so I'm just going to take 1/4 of 24. So that would be 6 students. Okay, now one strategy, if you need more time on this, you can go ahead and pause the video as needed as you're looking at these videos. That's also a video watching strategy that'll be helpful for you. Second question, what is the probability that a student in the class does not have glasses? Well, if 1/4 does have glasses, that means that 3/4 do not have glasses, because all of my events have to add up to 1, and I know that it's either wearing glasses or not wearing glasses. That would have to make up the whole population. So that makes 4/4, which is 1. That's how I can check. Okay, new question. If 8 students wear glasses, how many students total are in her class? So this is different than the first one because I don't know how many students are in her class. So if 8 students are 1/4, that means I would need to take 8 times 4 to figure out how many students are total, which would give me a total of 32 students. And then lastly, we're going to look at Flo and her pancake flipping business. Fun fact, when we make pancakes with our kids, we flip the pancakes to them and try to have them catch them on their plate. It's super fun. All right, so let's look at this. Flo thinks she might be able to increase sales if she makes a big show of flipping pancakes at her diner, but flipping pancakes high in the air takes a lot of practice. After flipping 35 pancakes, only 22 landed on the grill. What is the probability of Flo correctly flipping a pancake? And it asks for it as a percent. So I'm going to go ahead and take 22 and divide that by 35 and tell you what that is as a percent. So I turn that into a decimal, the first 5 decimals, which is way more places than I need, is 0.62857. So if I want to make that a percent, I'm going to make that 62.857%. Okay, Flo needs 42 pancakes for a large hungry group that just arrived. How many pancakes should she attempt so that she can flip 42 correctly? So I need to know 42 out of some total. And I know what her accuracy, I know she's about 0.62857. Or I could even use the 22 out of 35. I could use the ratio that I know that she's good at, the 22 out of 35. This is how many landed. The top number is how many landed on the grill. And then the bottom number was the number attempted. So if she wants to use that same rate, if she wants to land 42, I need to know how many she should attempt here. And I actually might like to leave it as this. I'm going to use 22 over 35 instead of that decimal, because this allows me to use my cross product property, which says I'm going to multiply 22 and x and set that equal to what I get when I multiply 42 and 35. Then once I get that multiplied, I'm just going to go ahead and divide by 22. 42 times 35 gives me 1,470, and then I just need to divide by 22 to figure out how many pancakes she should flip. And when I divided that, I got an answer of about 66.8. But I'm talking about flipping pancakes. I cannot flip 8/10 of a pancake, so I'm going to say she needs to flip 67 pancakes to guarantee that she's going to land 42 of them.